3:15, right? Last 1 minute. 1 minute is there. All these callers are advised to join immediately. Why? Because the session is going to commence very shortly. Yeah. Right. Let me. Good afternoon. Once again. Let me introduce the today's expert, Professor S. Srinivas Kumar. Dr. S. Srinivas Kumar is the Faculty of Electronics and Communication Engineering since 1987 in JNTU, Hyderabad, and worked in its constituent college, JNTU College of Engineering, Anantapur and Kakinada. He worked as the Vice Chancellor, JNTU Anantapur, from 2017 to 2020. He taught 18 theory courses in undergraduate and postgraduate program. In addition, he involved in the development of new laboratories, namely microprocessors, microcontrollers, computers laboratory, signal and image processing laboratory, funded by AICTE New Delhi, and also funded by World Bank project, TECIP, respectively. He has involved in conducting various laboratories from basics to advanced laboratories in electronics and communication engineering. He organized many workshops, seminars, and webinars for the faculty in electronics and communication engineering and hackathons for the students. The areas of these workshops, webinars, and seminars include signal and image processing, research methodology, intellectual property rights and patenting, etc. He delivered more than 85 invited lectures in UGC Academic Staff College, Hyderabad, Engineering Staff College of India, and many other reputed academic institutions. He is always keen to learn subjects in the discipline of ECE and disseminate the same to the students. He guided more than 80 undergraduate projects and 50 postgraduate theses in the area of his expertise, signal and image processing, and artificial neural networks. He attended number of workshops, webinars, and seminars. He was a member of the Board of Studies in ECE in several universities and examiners for many state and central government organizations. He was the member of Governing Council and Academic Senates in affiliated institutions of JNTU Kakinada as well as Anantapur. Dr. Kumar is active in research since 1994 onwards in the areas of signal and image processing. He published 140 research papers in reputed national and international journals and conferences, proceedings, and books together. He successfully supervised 18 research scholars in the areas image processing, antennas, and computer networks. 3 of these PhD theses have been published as monographs by Lambert Publishers, Germany, due to the number of citations of the research papers from these theses. He reviewed several research papers and was the examiner for the PhD thesis for other universities also. He is active in professional societies, namely ISTE, IETE as a life member, and a fellow of AP Academic Science, Academy of Science, Hyderabad, and a senior member in IEEE. Dr. Kumar is one among the professors who have taken active role in administration to glorify this university. He was the training and placement officer from 2001 to 2005, nodal officer to implement the World Bank project, TECIP, of worth rupees 11.258 crores 2005 to 2009, head of the Electronics and Communication Engineering Department from 2006 to 2009, Director of Sponsored Research 2009 to 2011, Director R&D 2011 to 2017, and worked as a Vice Chancellor from 2017 to 2020. He was responsible for starting MTech food processing in JNTU Kakinada in collaboration with the Ministry of Food Processing Industries, New Delhi, by presenting the project in Ministry of Food Processing Industries in New Delhi. In addition to the enthusiastic contribution in all administrative positions held during his career, he worked with dedication, sincerity, and commitment. He glorified every administrative position by selfless contribution. Accrediting the institute by TCS, L&T, and many other reputed companies as training and placement officer, successful implementation of the World Bank project, and placing the institute in first position in combined state of Andhra Pradesh. Obtaining the UGC 2-year 12B status to JNTU Kakinada after trifurcation of JNTU Hyderabad, getting the sanction of UGC 11th and 12th plan funds to JNTU Kakinada. Successful conduct of many competitive examinations at state level are some of his noteworthy contributions. In addition, as a Vice Chancellor, he contributed to develop JNTU Anantapur in both academics and infrastructure. Many of his noteworthy contributions as Vice Chancellor elevated the status of JNTU Anantapur in both state and national level. He successfully completed his tenure as the Vice Chancellor and resumed to his office at JNTUK as Professor of Electronics and Communication Engineering in December 2020. In spite of all these things, friends, he is a popular teacher, very good human, right? He is instrumental in developing R&D, research and development in JNTU Kakinada. Just whatever I read for 5 minutes, that is a minimal thing, right? I advise you, I request you all, please utilize this session, please attend this session, utilize this session seriously and enhance yourself. He prepared the PPT. I have gone through each and every slide, friends. Meticulously he prepared. Each and every word is very, very important. Hence, I request you all, please utilize this session and enhance your research ambience. Sir, Srinivas Kumar sir, sincerely request you to handle the session.
Am I audible, Dr. Krishna Prasad?
Yes, sir, you are audible, sir. You are audible clearly. PPT is also visible.
Which I put on the screen, is it visible?
Yes, sir, it's visible.
Okay. Thank you, Dr. Krishna Prasad. And I'm very happy for giving me an opportunity to address the research scholars. Rather, when I joined as a director R&D way back in the year 2012 till date, every year I'm addressing the scholars in the areas of research methodologies and industry 4.0 technologies, either offline or online. I request all the students first please mute your mic system immediately. All the research scholars may please mute your mic system. And I will be presenting nearly 127 slides, which is very, very important. Every slide is very important. And if you have any doubts in your class, in your notes which you are having, mention the page, mention the slide number where you have got a doubt. At the end of the lecture, I will be giving you nearly 10 to 15 minutes. And during that time, you can raise the questions and I will definitely clarify your questions. And please note down my mobile number 800-891-7555 and my personal email address is samayamantula1963@gmail.com and my university, rather a college email address is samay_sk2@jntucek.ac.in. Please note down these details, and if you have any clarifications that are required in future, you can approach me because I worked for a long time, nearly 8 years I worked as a director R&D, and during that time many scholars, they know me pretty well, how we have contributed for the directorate R&D. Today, whatever the university status in the research front is because of you, because of the research scholars which this particular university is having. And you have published or you are going to publish many research papers in the name of Jawaharlal Nehru Technological University, Kakinada. Thereby, it will be very, very useful to the university in terms of NIRF ranking or NBA accreditation or NAC accreditation or many, many aspects. The university status will definitely improve by your presence as a research scholar, and I heartfully invite you to Jawaharlal Nehru Technological University, Kakinada, as a research scholar. I'm sure you will have a good quality research outcome, as well as you will have a good research papers, or you will be having a good patents. And I'll be presenting you overall view about what the research is and how you can contribute, how to write the PhD thesis, and what are the industry 4.0 technologies, how you can link the industry 4.0 technologies to your research, and how to choose your area, how to select your topic, and what are the research tools. So many aspects I'll be covering in my lecture. Please take a pen and paper or a notebook, and whatever the presentation is there, the presentation will be given to you. It is not secret. That entire presentation will be, I think it will be sent by email to all the students. I'll be presenting my lecture now. I would like to just mention the difference between the invention and innovation. People say very, very synonymously the invention, innovation, but invention and innovation, these two are completely different. And you can see that if you create a new product, or if you introduce a new process for the first time, then it is considered as invention. And you say that the telephone was invented by Graham Bell. Yes, because telephone was first created, or that particular one has been popularized, or that particular telephone was the outcome of one gentleman, Graham Bell. So we say that the telephone was created by Graham Bell. So that is an invention. Another thing is innovation. And innovation means if you do some changes to have significant contribution from the outcome of the inventor, then that is considered as an innovation. Today we say Graham Bell has invented the telephone, but today whatever the one which we are enjoying, that is a mobile phone with so many features, are nothing but because of so many innovations. That is, invention cannot be used for innovation, and innovation cannot be used for invention. So invention and innovation are completely different. If any product is developed for the first time, then we say it is considered as an invention, and modifications that take place in that particular product to improve the quality of the product, or to improve the performance of the product, or to have more contribution from that particular product is considered as innovation. Invention, innovation, both are completely different. And if I throw a pebble means Gulakaraya. If I throw a pebble into the pond of water, the first ripple that comes out of it is considered as invention. And the one who tossed the pebble is considered as an inventor. And from that particular ripple, one will not get only one ripple, but the subsequent ripples they come, even without tossing the pebble, there are one wave that comes out of it because of the tossing of the pebble, and the subsequent waves that come out of it are considered as innovations. So I'm repeating this so that you will have a clear idea between the invention and innovation. If I throw the pebble into the pond of water, the first wave that comes out of it is like an invention. Or the subsequent waves that are coming out of it are considered as an innovation. We say that the Graham Bell has invented the telephone, and Bell was awarded his patent for the telephone on March 7, 1876. It is worth mentioning and worth recollecting the names of some great people who are responsible for today's our living condition. Had there been no telephone or had there been no mobile phone today, we can see the quality of the life which we are having. It is only because of the inventor Alexander Graham Bell, who has invented the first telephone in the year 1876, March 7th, and he has been awarded the patent for the telephone which he has invented. And every one of you knows Albert Einstein. He's a German-born theoretical physicist, and he has developed the general theory of relativity, one of the two pillars of the modern physics. In the year 1921, Einstein won the Nobel Prize for Physics, and the work which has contributed in the physics is the general theory of relativity. Every one of you knows about the theory of relativity. It is not the time to discuss more details about the what they have invented, but Albert Einstein has been given Nobel Prize for his invention, and for physics he has been given Nobel Prize. Aryabhatta, you know pretty well, the Aryabhatta has invented zero, and had there been opportunity to patent to apply for the intellectual property right for the invention which Aryabhatta has made, India would have been the richest country, and but unfortunately at that time, intellectual property right particular aspect was not there. So we can remember and recollect the memory from our memories, the quality of the work that was contributed by Aryabhatta, who has invented zero. He is an Indian. Wright brothers, and they have seen the bird which is flying in the sky, and they felt, why not they think of having the aircraft. And what they have done is they have invented, they have been inspired by seeing the bird, and they have invented the aircraft. And Wright brothers are one who are responsible for today's airplanes and the comfort which we are enjoying by traveling. And see the qualifications of the Wright brothers. And Arvel Wright has completed only 3 years of high school. Wilbur Wright has completed only 4 years of high school, but their qualifications are not the criteria, but they have invented the aircraft only by their interest, by abilities, by their perseverance. They could able to see that today we are enjoying the outcome of their invention. That is Arvel Wright and Wilbur Wright, who are not actually highly educated. Only 3 years of school or 4 years of school they studied, but still they have the passion to do something good, and they invented the aircraft. Today we are enjoying the outcome of their invention. And inventor Thomas Edison. And you can see today the light which we are having through the electric bulb is because of the invention of Thomas Edison. Thomas Edison had amassed a record of 1093 patents, 389 for electric light and power, 195 for phonographs, 150 for telegraph, 141 for storage batteries, and 34 for the telephone. The invention which he has made, now it has come after so many innovations in the form of a LED bulbs. You can see the invention which he has made is very, very useful. Today, we would have not seen the various aspects during the night time had there been no electric bulb. So everyone should have a remember and recollect the invention made by Thomas Edison. Electromagnetic. And the magnet was made by 18 tons of bare copper wire. And William Sturgeon is the one who has invented the electromagnet. And it is worth remembering and recollecting the invention by William Sturgeon. And every one of us today, how the magnet is functioning, every one of us know. And when the current flows through that particular copper wire, it acts like a magnet. And easy electro and I mean EEG, ECG, EMG, PET CT scan, CT scan, MRI scan, ultrasound scan. All these are the inventions from our engineers which are being used by the medical field. And please do remember, the days have gone to say that we belong to a particular discipline, so we will work only in that discipline. No, it is not correct. We have to think more about the interdisciplinary and multidisciplinary activity, which I will be presenting it to you slowly. And William N1 is the inventor of ECG, who won the Nobel Prize in the year 1924 for medicine. And heartfully, we have to remember his contribution. Had there been no ECG, we would have not been in a position to know the condition of our heart. William Etowen, and he has won the Nobel Prize for medicine. And Raman effect, and he was a recipient of Nobel Prize for physics in the year 1930 for the discovery that when light traverses a transparent material like prism, and the light disperses and based on the wavelength. And this is what his invention is. He was awarded Nobel Prize for physics in the year 1930, and excellent contribution that he has made has been recognized, and he was awarded Nobel Prize. I will be discussing more details about the group of Nobel Prize winners from our country in another few minutes. Madam Mary Curie. Madam Mary Curie became the first woman to win a Nobel Prize, and who has won the Nobel Prize both in the physics as well as in the chemistry. Curie's effort with her husband Pierre Curie led to the discovery of polonium and radium. And after Pierre's death, that is her husband's death, she didn't stop. She continued her research and further development to the X-rays. And do remember the Mary Curie, who is the first woman to win the Nobel Prize for her contribution, and she is the one who has contributed very well for the X-ray. Madam Mary Curie is remembered by all of you. Right? And Shiva Ayadurai, he is an Indian-born American scientist. He is an Indian-born American scientist. And as a high school student in 1979, he developed an electronic version of the inter-office mail system, which he called email, and he has applied for the intellectual property right and copyrighted in the year 1982. Shiva Ayadurai is an Indian-born American scientist, and as a high school student in 1979, he developed an electronic version of the inter-office mail system, which he called email. Today, we are enjoying that email because of the efforts of Shiva Ayadurai. He is an Indian-born American scientist. I would like to just mention about various groups of the people and who are the Nobel Prize awardees. All of them mostly are Indians. You can see the Abhijit Banerjee. Abhijit Banerjee is an Indian-born American economist who won in the year 2019 for the Nobel Prize in economic sciences, and his work is on experimental approach to alleviating global poverty. So experimental approach to alleviating. Remember, Abhijit Banerjee is an Indian, and his contribution is an experimental approach to alleviating global poverty. He studied, where did he study? He studied at University of Calcutta and Jawaharlal Nehru University before earning his PhD in economics from Harvard University in the year 1988. Please see very carefully. He did his undergraduate program and postgraduate programs only from India. He has studied in University of Calcutta and Jawaharlal Nehru University, New Delhi. He is the winner of Nobel Prize for his contribution in economic sciences. Amartya Sen, and he has won the Nobel Prize in the year 1998. His contribution is also in the economic sciences. His undergraduate studies is from Presidency College, Calcutta, and his graduate studies are from Trinity College, Cambridge. But his basic are the first he has been established only from Presidency College, Calcutta. Rather, that was renamed later as a Calcutta University. His undergraduate program is from Calcutta University, and do remember, he is also Indian. Mother Teresa, though she is not from India, but she settled in India, and she taught at St. Mary's High School in Calcutta for 17 years, eventually becoming a principal. She is a Nobel Peace winner, Mother Teresa, in the year 1979, and she is to be remembered by all of us. And she has worked in Calcutta, St. Mary's High School for 17 years, eventually becoming a principal. Rabindranath Tagore, Nobel Prize in Literature, and he was a self-taught poet. He is a songwriter, playwright, and painter, and the first non-European Nobel laureate in the literature in the year 1913. He has won the Nobel Prize. Hargobind Khorana, he is a Nobel Prize in physiology or medicine, and he is considered as a father of artificial DNA synthesis, especially and specifically creating the first synthetic gene. Is considered to be Nobel Prize winning Indian American biochemist Hargobind Khorana, and he has won the Nobel Prize in the year 1968. He is also Indian. Subramanian Chandrasekhar, few minutes back we were talking about C.V. Raman. Subramanian Chandrasekhar is a nephew of C.V. Raman, and he has worked in the structure of stars and stellar evaluation, black holes, and he was awarded a Nobel Prize in Physics in the year 1983, and Chandrasekhar studied only at Presidency College, Madras. Now we call it the Chennai, and the University of Cambridge, and he is an Indian. V.S. Naipaul, he is also a Nobel Prize winner in literature. See, Venkatraman Ramakrishnan is a Nobel Prize winner in chemistry in the year 2009. He did his undergraduate program, Bachelor of Science in Physics, in 1971 from Maharaja Shivaji Rao University in India, and a Doctor of Philosophy in Physics in the year 1976 from Ohio University in the United States. Key contribution is the determination of the atomic structure of ribosome using X-ray crystallography, a discovery that earned him the Nobel Prize in Chemistry in the year 2009. He is also an Indian, and from a very normal college like Jawaharlal Nehru Technological University. He is from Maharaja Shivaji Rao University in India. Another Nobel Prize winner, you know pretty well, Kailash Satyarthi. He is a Nobel Prize winner for peace, and he holds a bachelor's degree in electrical engineering and postgraduate diploma in high voltage engineering from Samrat Ashok Technological Institution, which is an affiliated institution for the Bhopal University. He is also a Nobel Prize winner. He is also in India. So from all this, I could able to say one point. All these are from our country, studied in a normal college like Jawaharlal Nehru Technological University, or even Kailash Acharya has studied his undergraduate program from a one private institution which is affiliating institution, but still see the perseverance which they have, they are the winners of the Nobel Prize. Where you have studied is not important. What position you have reached is important. Have been proved by all these Nobel Prize winners. See, no one is from IIT, no one is from NIT system. All these Nobel Prize winners are from our ordinary colleges, ordinary universities, our state universities, our presidency college, Calcutta, or now it is a University of Calcutta, our presidency college, Chennai, or Bhopal University, and from this kind of universities only they did their undergraduate program, but the position which they have reached, they are the Nobel Prize winners. Where you have studied is not important. What position you have reached is important. You might be working in an affiliated institution when because of your own personal problems, you might be working as a part-time scholar, but I'm sure even today you can do miracles in your life by concentrating in your research and producing a high quality research papers, producing a high quality patents on the intellectual property rights, and I'm sure that you can bring the laurels to you, to your family, as well as to the university where you are working and to our university where you have registered for PhD. So I sincerely advise you, please forget where you have studied, what your background is, but I'm sure that you all research scholars can do miracles in your life only by having a perseverance, determination, honesty, integrity, and overall performance for the quality outcome. I'm sure that you will be the winner. And so far I discussed about the inventors. But now I would like to say one example simply, one innovator. Dr. Vishal Rao, a Bangalore-based oncologist, is a cancer specialist, has developed a voice prosthesis that can help the throat cancer patients speak after surgery. You can see, you will find a voice prosthesis and that may not function because of the oncology problem, and that particular one can be made to be active, and he just found a device with just 50 rupees and he was able to see that particular voice prosthesis can be used for making the patient to speak. That is considered innovation. So I sincerely advise you to distinguish between the invention and innovation. Invention is the one which is developed for the first time, and if you do several modifications to the product or the process, then it becomes the innovation. So to see the difference between the invention and innovation, I have given the examples and I mentioned the Nobel Prize winners, and I told you clearly that you people forget where you have studied your undergraduate program, where you have studied your MTech program or postgraduate program, or where you are doing your PhD are not important. But what position you want to reach, that is more important. And your innovations or your inventions should clearly give a path, and see that that particular work which you contribute should be more useful for the research. And just one day back, when I was talking to one industrialist, he was clearly saying that the academic research dynamics have completely changed. Now, people earlier, when we were working more emphasis was given for the research papers, but now emphasis is to be given for the industry-oriented work, thereby for the patents or the copyrights or for intellectual property rights. You have to emphasize. That is, I don't say don't give emphasis for the research papers, but you think that the research papers are important, publications are important in high quality journals, but at the same time, you need to get the patents or industry relevant work. If you do, that will be more useful for the industry as well as for the society. And societal relevance for your 4 years contribution will be very useful. I sincerely advise you to work preferably industry or a society relevant works than publication oriented work. But I do not say that you stop publication oriented work. You work because once when you start the work, you think in that direction. One person's half-baked suggestion resonates in the mind of another person, and finally it takes a definite shape. Definitely, when you start some work, that work should be continued, get it published, get inspired, then slowly move towards the industry oriented or a society oriented or society relevant work that will bring you laurels. I would like to mention the words of Arya Mashelkar, whom we have given a honoris causa at Jawaharlal Nehru Technological University, Kakinada, and I am very fortunate enough to read his citation from the dais. His words I would like to repeat: child-centered education, woman-centered family, human-centered development, knowledge-centered society, innovation-centered India. Very, very important, and the government is emphasizing for all these five factors. Child-centered education, woman-centered family, human-centered development, knowledge-centered society, and lastly, or not last actually, innovation-centered India. That is, we should think in terms of innovations, new product that will be changing the lifestyle of the human being, lifestyle of the society, and industry relevance should be brought. That is the reason I emphasize that you people work with innovation, innovative thinking, and try to find more society relevant work or industry relevant work that should create the path for new products or new processes. So I would like to repeat the words of Arya Mashelkar once again: child-centered education, woman-centered family, human-centered development, knowledge-centered society, and the last one is innovation-centered India. And I used to say very frequently that the knowledge, skills, and values, these three are very, very important to be considered. Even in the recent national education policy, they have emphasized knowledge, skills, and values. So I say that the knowledge is further classified. I say that there are six wings of the knowledge: knowledge acquisition, knowledge application, knowledge evaluation, and lastly, knowledge creation. I would like to repeat again: knowledge acquisition. As a teacher, I should read the textbooks, I should go through the online material, I should go through the various research papers, I should discuss with groups of the people, I should try to acquire as much knowledge as possible. That is my first rather duty. And what are the knowledge which I acquire? And what are the knowledge which I acquire? I should disseminate to the students. That is, I should teach them. I should mold the students. And I should create the platforms for the acquiring new knowledge by the students. That is what is called as a knowledge dissemination. That is also my responsibility. And as a teacher. And what are the knowledge which I acquire? I should be in a position to preserve the knowledge, either in the online or a YouTube links or in some form or other. I should preserve the knowledge. So my third responsibility is knowledge preservation. And whatever the knowledge which we acquire, that should be applied for the society. And society lifestyle improvement, or its its quality improvement of the individuals. That is knowledge application. So knowledge acquisition, knowledge dissemination, knowledge preservation, and the fourth one is considered the knowledge application. And the fifth one is considered the knowledge evaluation. As a teacher, I should be in a position to see whatever the students' knowledge which he acquires through either classroom teaching or a collaborative learning or a self-learning or a flipped learning or experimental learning, and whatever the knowledge which he acquires, I should be in a position as a teacher to evaluate the knowledge. And not only these five responsibilities, I have an additional responsibility. I should create the new knowledge. That is knowledge creation. That is what you call it as a research outcome. So the six wings of the knowledge, and today as a research scholar, you have an additional responsibility that you should create the new knowledge, knowledge acquisition, knowledge dissemination, knowledge preservation, knowledge application, knowledge evaluation, one which you have to work for the next 3 or 4 years, and to get your PhD. Even after getting PhD, you should continue to work even till your last breath. You have to create new knowledge. That is what is called as a knowledge creation. I would like to just mention how the education and research, what it means. Education is the primary means for achieving national awakening, and research is a means for national development. And both are very important. National awakening is important, and national development is also equally important. And education means only the first five steps which I discussed. That is the knowledge acquisition, dissemination, preservation, application, and evaluation. All these five will try to consider the education as the primary means for achieving a national awakening. And the last one, knowledge creation, that is a research, is a means for national development. And as an individual who is having a good quality life in the present day, we have to, and as a teacher, studied, having a good qualification, and also working in one of the good institutions, your job is both education as well as a research. Both are equally important. And I would like to repeat the words of Swami Vivekananda, and these words repeatedly I say in several of my presentations. Purity, మన మనసు నిర్మలంగా ఉండాలా. Patience, ఓర్పుగా ఉండాలా. Perseverance, పట్టుదలగా ఉండాలా. Purity, patience, and perseverance are keys for the success above all level. And these are the words of Swami Vivekananda. When you work for your PhD, see that your heart is pure, you should be patient, and you must be with perseverance. చాలా ఓర్పుగా ఉండండి and పట్టుదలగా ఉండండి, and I'm sure that you will succeed. So I would like to repeat the words of Swami Vivekananda once again to see that these words, and you should remember and repeat by yourself number of times so that your mindset will change. Purity, patience, and perseverance are keys of success above all level. And this one I have discussed already. One person's half-baked suggestion resonates in the mind of another person, and suddenly it takes a definite shape. This part is very, very important. The reason is you will be reading one research paper, and you will see, yes, in this paper they have used a fuzzy set theoretic techniques, and they solved the particular problem. And don't you find any other way to solve the problem? Because most of us are making use of a applied research, which I'll be discussing further. So you can think of improving the performance of the research paper and research outcome by considering any other steps. So one paper has given you the area and also the idea with which they have worked, and that particular research paper outcome can be improved, and you can get a better outcome by considering a new method, and that is what is called the research. So initially you cannot say some research work. You have to find some quality research paper as a base paper, read that base paper, understand it, implement it, and find the new tools and new methodology to solve the same problem in a different manner so that you will get a better outcome. So one person's half-baked suggestion resonates in the mind of another and suddenly takes a definite shape. And this word, I have taken it from one textbook and that I'm putting it before you. So I sincerely advise you, please read recent research papers, understand them, try to produce high quality research by changing the quality of the research outcome. Now I would like to repeat the various types of research. I would like to say there are 4 types of researches which I would like to present: basic research, qualitative research, quantitative research, and applied research. I'm repeating again: basic research, qualitative research, quantitative research, and then applied research. These are 4 areas where the research is classified: basic research, qualitative research, quantitative research, and then applied research. I'll be giving you the information about these 4 researches. And basic research is mostly worked out by mathematics people or physics or chemistry or science group of people. They work on basic research. The research is for knowledge enhancement. There is knowledge enhancement and no immediate commercial potential, and human welfare, animal welfare, and plant kingdom welfare is to be considered in the basic research. It is called as a basic, pure, and fundamental research. There is no immediate application of what the outcome is, but in future they may find the outcome by applying the research outcome of this basic research in applied research. So I say the basic research is only for the knowledge enhancement. Example also I have given: how did this universe begin? If you start thinking, working in that kind of areas, then that kind of work is considered as basic research. People cannot foresee the future well enough to predict what is going to develop from the basic research. Whatever the outcome which you get from this basic research, it may be useful for applied research at later time. So it is not having immediate application. There is no immediate commercial potential for the contribution which you make, but it may be used in future. It is basically used for knowledge enhancement. Then that kind of research is called as a basic research. All these PowerPoint presentations will be given to you, need not worry. And if you have any doubt, please note down the slide number. At the end of the presentation, I'll be discussing more details with all research scholars, giving you the clarifications for the doubts which you raised. Another one is applied research. Applied research, suppose if I'm first give you the examples, then I'll give the discussion about them. Right? When, if you consider agriculture crop production, earlier, you know that for each acre we used to have only 20 bags. Now active research was carried out. Now we are having 40 bags per acre. That is only by improving the agriculture crop production. This is, you could able to achieve it by applied research. And let us say, earlier people used to say that there is no treatment for the cancer, but now cancer is easily curable. So treat or cure a specific disease is considered as one of the applied research. Earlier people used to say the one Edison has developed the bulb, electric bulb, but now you are making use of LED bulbs or improve the energy efficiency of the homes and offices. This is also considered as an outcome of the applied research. Improve communications. People used to say 2G communication, 3G communication, 4G communication, 5G communication. people say, don't say OC is not communication, right? 1G, 2G, 3G, 4G, and now 5G, and say how the communication has increased, the quality of interaction between the two people or from between two groups. This is also outcome of the applied research. So applied research is having the immediate application and it is having a commercial viability. So whatever the new idea which you get, and that new idea will try to implement for the available work, and the new tools are considered and new tools are applied, so the research outcome will be very well improved. Applied research is designated and designed to solve practical problem of the modern world rather than to acquire knowledge. And as I was telling you, in the basic research, we try to do for knowledge enhancement, whereas in the applied research, we try to improve the quality of the human life and also to see that it is having immediate commercial applications. Applied research is an investigation for ways of using scientific knowledge to solve the practical problems. As I have given the examples, one is improving the agriculture crop production, treat or cure a specific disease, improve the energy efficiency of homes and offices, improving the communication are the outcomes of the applied research. And here I would like to say that the applied research is having two types of works. Again, they are classified. One is a problem oriented research, another one is a problem solving research. One is a problem oriented research. Let us say there is a problem with the television industry, and we try to work out, and whatever the research outcome that comes out of that particular one is not only useful for one particular industry in the television. It may be used by the Samsung, or it may be used by the LG, or it may be used by the Videocon, or it may be used by any other television industry. That is, the problem oriented research is the one the outcome can be useful by all the industries in that particular sector. Whereas problem solving research is the one which can be useful only for that particular industry. Let us say Samsung is there. Samsung is having a one particular problem, and if you try to solve the problem, and that particular work will be useful only for that particular industry, that is only for Samsung. It cannot be used for the LG or any other industry. So a problem-oriented research is more broader perspective, and problem-solving research is a narrow perspective. That is, whatever the outcome which we get out of the problem-oriented research is useful for all the industries in that particular sector. Whereas problem-solving research is useful only one particular company can make use of. So try to classify the whatever the applied research is again further classified into two types. One is a problem oriented research, another one is a problem solving research. There is another type of research, that is a quantitative research. I'll try to be a little bit fast because by 5:30 I should complete. And quantitative research, and here we make use of mathematical models, statistics, and try to see what the outcome which you can expect out of it. I will just give you some examples here. Let us say soap industry is there. I will go to the next slide. The soap industry is there. In 2000, let us say now it is 2025, and 2023, the demand for the soap is like this, supply is like this. In 2024, the demand is like this, the supply is like this. In 2025, again, demand is like this, supply is like this. And we have to predict the mathematical, you have to find some mathematical model based on the demand and supply, and try to predict what is the outcome, what is the demand and supply in 2026 or 2027 or in 2028, for which based on the previous data, we have to find some new mathematical model, and from that mathematical model, we should be in a position to predict what the demand and supply in 2026, what the demand and supply in 2027, or what the demand between 2020 to 28, that we will be able to achieve that. That is what is called a quantitative research. So in quantitative research, we give the importance for the mathematical models or statistics, based on which we try to give the quantitative information for the future, that is future requirements. Another one is a qualitative research. Well, I'll give here also give some examples. When I was in the Omega Hospital at Hyderabad, I was sitting in the corridor, and some girls have come, and they are the management students. They are asking me, "Sir, are you satisfied with diagnostic tests? Yes or no? Yes. And are you satisfied with the ambience of the hospital? Yes. Are you satisfied with the doctor's prescription? Yes. Are the medicines available in the hospital? Yes. Like this, they try to get some information from us, maybe based on the good, excellent, not good, and satisfactory. Like this, they get the information, and based on which, based on this qualitative outcome, they try to improve upon the quality of that particular hospital. And this kind of work is considered as a qualitative research. I'll give another example. When I was going abroad in Korean airport, I was sitting along with my wife, and some Korean girls have come. They asked me about the aircraft, that airport condition, and they asked me the various examples. They asked me whether the ambience of the airport is good or not, whether the restrooms are good or not, whether the canteen facilities is good or not. Like that, they are asking various questions, and from these questions, they are trying to say qualitatively what the condition of the airport and where they have to improve upon. That is, basic research is the one which is not useful for commercial applications, but that particular knowledge which you have, that can be used for the future. Applied research is the one which is very useful. It is having a commercial applications. Quantitative research is the one which gives you the which can be used, wherein we can make use of mathematical models, and from the mathematical models we try to find what the outcome which you can have. And the qualitative research is the one where you will have a information about good, not good, excellent, satisfactory, bad, or very bad. This kind of information gives you the qualitative information from which we can improve upon. This kind of work is called as a qualitative. So broadly, the research is classified into basic research, applied research, qualitative research, quantitative research. I would like to skip this particular slide, right? So that is one type of classification. I would like to present another way of information about the types of research, that is called as intradisciplinary research, multidisciplinary research, interdisciplinary research, transdisciplinary research. I would like to repeat it once again. Intradisciplinary research, multidisciplinary research, interdisciplinary research, and transdisciplinary research. That is the four types of research. In the next few slides, I would like to explain. But before starting the next slide, I would like to give the gist of what these four areas are. Let us say I'm interested in the electronics and communication engineering, electronics in particular, and first we study the electronics, then we study about the VLSI design, then we study about the system on chip, Then we study about the same area, the same VLSI design area. If I try to develop within the same area, then it is considered as interdisciplinary area. Or let us say you want to consider in machine design, in mechanical engineering, and the machine design you are having various steps, and you want to go for the advanced machine design, then and that is considered interdisciplinary. Within the same discipline, if you develop, then then it is considered as a interdisciplinary research. Let us say there is another way between subject areas. In the between subject areas, there is a interdisciplinary is within the same subject, and multidisciplinary is between two subjects or between multiple subjects. So let us say the Ganga River. Ganga River is to be cleaned, but you need an environmental specialist. You need a civil engineering to strengthen the riverbeds. You want another water pollution controlling engineer, and you need different disciplines. And see, the civil engineering person will come. He will try to see that the riverbeds are strengthened. An environmental pollution person will come. He takes care of the water. And another gentleman will come and he will take care of another discipline. See, each discipline is independent. This word is very important. Please remember. Each discipline is independent and they take care of overall about the cleaning of the Ganga River. Then this kind of work is considered as multidisciplinary. I will give another example. Let us say I want to construct an intelligent building, and when I try to clap first, the door should open, and immediately if I clap twice, the air conditioner switch on, lights should switch on, and if I do the 3 times the clap, then immediately I should get the food cooked and I should get the food before me. And that is the types of where electrical engineer is required, electronics engineer required, mechanical engineer required, or civil engineer required. But all these are independent. You can see in your class, a civil engineer person where you are delivering the lecture, a civil engineer will come and he constructs the structure and he leaves. A mechanical engineer will come, he tries to fix the air conditioners, he leaves. An electrical engineer will come and he's trying to see that the electrical switches and electrical lights all are fixed and he leaves. Electronics engineer will come, he tries to take care of the LCD projector and he leaves. A computer science person will come, he tries to see that the necessary software is installed in the computer system and he leaves. Finally, you are having in a classroom with electrical lighting, good structure and air conditioned classroom, as well as with the computer and LCD projector. Each discipline is independent. Each discipline is independent. In that kind of work is considered as multidisciplinary area. That kind of work is called as a multidisciplinary area. And there is another area that is what is called as an interdisciplinary area, where the disciplines are dependent on each other. Multidisciplinary area is the one where the disciplines are independent. Interdisciplinary is the one where the disciplines are dependent on each other. Let us say the mechanical engineer, electronics and communication engineer, they join together. They will try to develop a robot. So when we want to develop a robot, both electronics is required and mechanical are required. Both are dependent on each other. Then we can find a robotics. Another one, bioinformatics, where the biology is required, computers are required, computer science engineering required. Both work together, they develop a bioinformatics. This kind of work where the disciplines are dependent on each other, that work is considered as interdisciplinary. So in a multidisciplinary, disciplines are independent, whereas interdisciplinary, the disciplines are dependent on each other. And the fourth one is considered as transdisciplinary. Whatever the outcome which I get in one particular discipline through my research, that outcome is not only useful in the same discipline, the outcome may be useful in the other disciplines also. That is what is called the beyond subject areas. That is, I do work in electronics and communication engineering. I produce a good quality research outcome. That outcome is not only useful in our own electronics and communication engineering, it can be used in the other disciplines also, and that kind of work is called as a transdisciplinary area. So, overall types of research, interdisciplinary, in the case of interdisciplinary, I try to develop in my own area. And among the subjects, if I start between two subjects, one is a multidisciplinary, where two or three disciplines, but these two or three disciplines are independent, but still we can produce a good research outcome. Interdisciplinary is the one where two or three or more disciplines are there, but they are dependent on each other. That kind of work is called as a interdisciplinary area. And the transdisciplinary is the one where the outcome is produced in one particular discipline. That outcome is not only useful in the same discipline, it is also useful in the other disciplines. Then it is considered as a transdisciplinary area. So, intradisciplinary, multidisciplinary, or interdisciplinary, or transdisciplinary is one type of classification of the research. And I strongly emphasize, even the central government or the state government is emphasizing, you please think of working either in the multidisciplinary areas or interdisciplinary areas, and there should not be any what you call it as a boundary for each discipline. You should be in a position to think about the other disciplines and try to learn the other disciplines and try to produce good outcome in the multidiscipline or interdiscipline areas. This is what the one which I have discussed. One is the interdiscipline, where the disciplines are multidisciplinary area, and you can see clearly here the difference between the multidiscipline. The research A has come and he works, and B has come, he works, but both work in the common problem, but both are independent. And A and B both are dependent, but they produce the C, that is called as a new discipline. Then it is considered interdisciplinary area. The transdisciplinary, a research strategy that crosses many disciplinary boundaries. And I told you already what are the outcome that comes out of it. One discipline that can be useful not only in the same discipline, it can be used in the other disciplines also. I will give the slides so that you can understand more detail. Intradisciplinary, within the same area, if I start working, and I have given an example also, if I start working only in the VLS design without considering the other disciplines, then you will get a quality work, but within the same discipline, that is called as the intradisciplinary area. Here I have given a diagrammatic approach. In the intradisciplinary, you can see the red circle which I have mentioned is the goal, arrow mark is the discipline, and I am trying to reach that particular goal and in that particular direction. Then the same goal can be reached by quality work in the same path, that is called as a intradisciplinary research. Another one is a multidisciplinary research which I have shown, and the goal is, I have told you already, one example also given, intelligent building. Each discipline is independent, but they have a common problem. The common problem is try to see the intelligent building is constructed, and this kind of work is considered as a multidisciplinary. Interdisciplinary, I given two examples there also. Robotics is the outcome of electronics and communication engineering, as well as the mechanical engineering. Both are dependent on each other. The outcome is interdisciplinary. And the last one is a cross-disciplinary, wherein the independent disciplines, they work, and the research outcome of one particular discipline is useful not only in the same discipline, it's also useful in the other disciplines. Then we say it is a transdisciplinary research. Well, people try to find the research topics which will be useful to the society. And air quality is one area, how to improve the air quality. Climate change, environment, optimizing the natural resources, that is what is called as a ecosystem management. Electricity, energy, environmental regulation, food and agriculture, forests, land use, marine resources, policy instruments, risk management, space, transportation, waste management, water, pharmacy, various engineering disciplines in the management. These are the areas where you can find one particular area which is useful to the society, and that area you try to find the research program which will be useful to the societal requirement or industry requirement. And suppose if I work to improve the air quality, yes, that is a good work. If I try to work to improve the environment condition, that is also good work. If I try to find the home appliances which consume less energy, yes, that is also good work. And if I try to produce a high quality food, that is also good work. And this kind of works are useful to the society, wherein the human life condition can be improved. Well, selection of the area of engineering, which is another important topic. Well, I have chosen the area first. Well, the area is in the electronics and communication engineering. I may be interested to work either in the signal image processing, or I may be interested in the communication engineering, or I may be interested in the VLSI design. Or if I consider engineering discipline like civil engineering, I may be interested in the structural engineering, or I may be interested in the soil mechanics, or I may be interested in the environmental engineering, or I may be interested in the transportation engineering. So that is what is called as a selection of area. Or if I consider computer science and engineering, data mining and data warehousing, or a mobile computing, or a computer architecture, or data analytics, different augmented reality, virtual reality, different areas are there now, and the industry 4.0
అక్కడ ఫ్యాన్
technology,
పెట్టేసి మోని
the computer science engineering, we can work in one particular area. And similarly, in the if I consider electrical and electronics engineering, the electrical workers like power systems, power electronics, or non-conventional energy resources, or integrating various non-conventional energy resources. This is the area where I can plan working. And mechanical engineering, thermal engineering, or production engineering, or machine design are the areas where you can work. So first, you have been allocated the discipline where you can work. In that particular discipline, you have to start thinking the area where you want to work. Once, let us say I have considered the area, let us say image processing is the area where I want to work. In the image processing, which topic I have to work? Shall I work in the image enhancement, image restoration, image segmentation, image mosaic, image matching, image registration, image watermarking, image inpainting, image compression, image fusion, image retrieval, super resolution, visual cryptography? Which topic I want to consider? This is considered within the area topic. Similarly, I have chosen, let us say, the pattern recognition is the area. In the pattern recognition, shall I work in the voice recognition, speech recognition, face recognition, iris recognition, character recognition, palm recognition, fingerprint recognition, ear recognition, or vein recognition, or DNA recognition, or speech emotion recognition, or facial expression recognition? Which topic I have to select? That is considered as topic. So, your first job when you want to start your work is the selection of the area and then the selection of the topic. So, selection of area, as I was telling you, whether you want to work in the signal image processing or a communication or a VLSD then, or if you are a civil, structural or a soil mechanics or environment engineering or a transportation engineering, where you want, which area, which topic you want to work, and it's the area you want to work. And once if you select the area, which topic you want to work, that is the one which is to be considered. So selection of the area, selection of the topic, these two must be finalized priorly before you start your supervisor and approaching the supervisor and working. Selection of the subjects in the coursework. Well, your first job is to see that the subjects, theory subjects are completed and you are having a pre-PhD examinations. When you consider pre-PhD subjects, they must be more relevant to the research. Let us say, if the area of the research is image processing, then I should work in the patternization, computer vision, image processing, statistics and random variables, transform techniques, or mathematics. All these subjects are relevant to the image processing. You should start planning your work by reading these books. So better if you consider these subjects as pre-PhD subjects. That is, you should complete your selection of the subjects for the coursework which are relevant to the area and the topic which you choose. And you have to read as many books as possible. All books may not be available in your library. And if you want to purchase even the books, they are very, very costly. Try to find some of the web links where you can download the books. And you can make use of those books and see those books are read. And if you feel that those books are very, very important, you can get them printed and you can read them. And there are very, very good books that are available. And those books, even in the recent MTech course syllabus, designing of the course structure and designing of the syllabus, I mentioned what particular books that are required. Those books may not be available, but they are available through online. You have to download those books and read them, understand them. And recently, even I was given one subject, software defined radio, and I have downloaded the relevant books, and those books will be read by me and the subjects will be taught by me. That is, don't think that the books must be available. You should try to collect the books through online and read them, understand them. So first your job is to see as many textbooks as possible in that particular area, in that particular topic. You must read, understand them and see what the basics of that particular subject is. And you have to start thinking about implementing the small projects in the area of the work, mini project, undergraduate project, or PG thesis. You try to guide, supervise your scholars, and comparison of the techniques in the literature. See, one particular research problem might be solved by X in one way, by Y in another way, by Z in another way. So you can compare the research outcome of X, Y, Z. So comparison of the techniques in the literature is equally important. Understanding the limitations, the disadvantages and the advantages. X has done some work. It is having some advantages, disadvantages, some limitations. Y has executed the same work, but it has got certain advantages. It has got certain disadvantages. It has got some limitations. Try to see that X, Y, Z, what are the outcomes which they produce, and those outcomes must be compared, and you should try to find the difference among the outcomes, understanding the limitations, disadvantages and advantages, and try to find the tools which can alleviate the disadvantages. That is, identification of new tools. Let us say earlier, long back, we used to work making use of a Fourier transforms. Then wavelet transforms have come. Then after wavelets, then you have got a curvelets have the, then contourlets have come. So many tools that have come and which is improving the performance of that particular quality. So identification of the tools is also equally important. And you have to collect as much literature as possible. Elsevier is a one publisher. IEEE Explore, ASME for mechanical, ACE for civil, ACM computing service. They have different websites. You try to collect the information regarding your area, regarding your different collecting the information from different books, different journals, different websites. And when you want to publish the journal papers, you try to publish the papers only in the repeated journals. Do not send the papers unnecessarily for the conferences or international conferences. But those are not repeated. But your paper may get published. Finally, the paper is not countable as far as the research outcome is concerned. So unnecessarily do not waste your time, waste your energy. You try to publish the research papers only in the repeated journals where it should have a impact factor given by Thomson Reuters. Thomson Reuters. And every journal they said that they have an impact factor, but you have to send the papers only to the journals having an impact factor given by Thomson Reuters. So publish papers only in the repeated journals. Sometimes very excellent conferences in Indian Statistical Institution, Calcutta, or some IITs they were conduct. So you can send the papers to those reputed national or international journals, conferences also. And there is another society that is called as a Indian National Scientific Documentation Center, INSDOC. Earlier it was there. Presently it is there or not, I do not know. And suppose if any research paper is not available, if you communicate that this paper we want, then they will try to collect that particular information and give it to us. Of course, this is a earlier when I was working for my PhD way back in the year 1997, I used to collect the information from the INSDOC, but I do not know whether it is required or not at present. And there are many online journals are there, IEEE online journals, and you can collect the information from the online journals. And you have to visit the libraries of higher learning institutions like ISA Calcutta, IITs, or central universities. You have to visit these libraries, try to meet the people working in your area, and try to see what they are working, and you can work in a group of people also. So the fundamental steps are study of survey papers, attending the conferences, discussing with other research scholars, acquaintance with the verbatim of the topic, application of the topic required, and there are some user communities are there. Suppose a person who is working in the watermarking, www.watermarkingworld.org, particular area, the websites are there where they will post some questions, and from the questions you try to get the information. And file sharing sites are there, mathworks.com. Frequently asked questions, white papers, tutorials, demos. Implementation of routine and standard basic algorithms which are thoroughly understood, and preferably collect all the research papers available in the area of research, in particular for the last 3 years. I'm emphasizing this particular point. When you are working in the year 2025, you try to collect the information which is published in the reputed journals only from the year 2024, 2023. That is, your work should start from 2023, 24, and 25. You do not consider the base paper which is published way back in the year 1970. That is not correct. So your work always must be initiated only from the last 3 years. So the base paper which you have to read, understand, study, and implement and develop must be from the last 3 years only. That is when you are working in the year 2025, 2024 or 2023 papers can be considered, but not before that. And earlier when we used to work only by using a C programming. When you want to write a image, I have to write a big program. When you want to display the image, I have to write a big program. And when I want to read the image, whether a TIFF format or a GIF format or a JPEG format, I have to write a very big program. That problem is not there now. The MATLAB has come, which we used way back in the year 1999, 2000. Before that, we used to work only in the C language. MATLAB has saved me, rather. I should thank the MATLAB Mathwork people. MATLAB and Simulink, LabVIEW, Cadence, ANSI software, Studs software, NetSim, AutoCAD, Octave, Mathematica, like that. Various software packages are there. You can work based on these packages. When you have developed one particular algorithm, that particular algorithm you have developed and you have tested that particular algorithm performance only on benchmark database. Benchmark means it is a standard database. That standard database which you choose. Let us say CBIR means content based image retrieval. When you want to work in content based image retrieval, there is a Corel database itself. When you want to work in biometric systems, that is iris recognition, or face recognition, or fingerprint recognition, or palm recognition, then there is another database, that is biometrics.idealtest.org. And similarly, when you want to work in a video database, video processing, the video databases are there. So you can work in either of these databases, right? And you should not have, because whatever the database which you use, earlier people might have used the same database, then only your work can be compared with the other work. If you use some other database than what the earlier people have used, then you cannot compare your work. You cannot compare the performance metrics of your work with the others' work. So naturally, the database for which you are working must be same as what others have done. And I told you that whenever you want to work, that quantitative performance is very important. Quantitative performance depends upon the area which you choose. Suppose you want to consider a signal compression, then what was the peak signal to noise ratio that was done by earlier people, and what is the PSNR, peak signal to noise ratio, by me? What was the entropy by them? What is the entropy by me? What was the compression ratio by them? What is the compression ratio by me? Then compare the performance. And then if you say that the performance of our work is improved upon over the earlier works, then it is considered as signal compression work. Similarly, watermarking, peak signal to noise ratio, normalized cross correlation, computational complexity, information hiding capacity. Like this, you can work in multiple performance measures are there. You have to compare your work with earlier works. Like that, for every area, the performance metrics differs. Data retrieval, the performance metrics differ. Similarly, image segmentation, the performance metrics differ. Like this, the performance metrics are to be considered, and these performance metrics are to be compared with work, and then you can say the performance metrics are improved upon, so your work is much better than the earlier works. So the performance metrics for very, very important to be considered. And I was just insisting upon that applied research is the one where you have to make use of research tools. And if you want to consider research tools, you may have to make use of some optimization techniques. So you must have an idea about the dynamic programming, simulated learning, genetic algorithm, artificial bee colony algorithm, or particle swarm optimization. These are the different optimization algorithms are there. So one should say why ABC algorithm is coming perfectly for a given problem. You should not say, yes, I got a ABC algorithm or artificial bee colony algorithm is considered for this work, So I got this outcome. So I'm publishing a research paper. No. Why artificial bee colony algorithm is superior over the other algorithms that you must emphasize. Similarly, when I say particle swarm optimization is giving a better performance, and I want to publish a research paper, it is not acceptable. Please do remember, whenever you consider any particular algorithm, let us say particle swarm optimization, why it is giving a better result, that you should justify the reason. Similarly, the neural networks is another research tool. Earlier, we used to work in multi-layer perceptron half-field network, adaptive resonance theory, or quantum network, or uh, when convolutional neural network, time distributed convolutional neural network, so many capsule nets and cascade correlation architectures. So many neural networks have come, and you can make use of them as one tool for classification purpose or for authentication purpose. Similarly, the people used to work earlier, I was telling you that you used to work in Fourier transforms. Now, not only Fourier transforms, wavelet transforms, curvelets, contourlets, S transforms are non-subsample contourlet transforms. So many changes have come in the areas of subband decomposition techniques. And support vector machine, deep learning, deep learning is convolutional networks, compressor sensing, sentiment analysis, or fuzzy set theory technique, rough sets, rough fuzzy sets, are statistical tools like probability, random variable, stochastic process, moments, estimation, non-parametric statistics, are mathematical tools like differential equations, partial differential equations, calculus, vector algebra, or matrix algebra, or trigonometry, or other tools like graph theory, combinatorial analysis, data structures, programming languages. So you must have the knowledge about the research tools which are required for your research. So initially, first you should start implementing one research paper available and find the limitations of the paper. That is, if you have one research paper in the year 2025 in the area of your work, you start implementing that particular research paper and find the limitations of the work and identify the tools which can solve the research problem effectively, such that one can improve the performance of the existing paper. Communicate the research papers only to the standard international conference, preferably only to standard journals. Do not unnecessarily communicate your research papers to unnecessarily some wrong conferences, and that will spoil your work. So I sincerely advise you, communicate the research papers only to the standard international conferences. Your mindset always must be balanced, very balanced. During the next 4 or 5 years, when you are working for your PhD, your thoughts must be very balanced. And whatever the idea with which you have worked, with some modifications, can be communicated to journals. And here I would like to tell you, you have communicated your paper to one high quality international conference, but that international conference paper which you have communicated and presented there, you can modify that paper and you can send that paper to journal also. That is, with one particular idea, you are having two feathers in your cap. One is for the international conference, another one is for the international journal. Initially, communicate the research papers only to single reviewer journals. I think you may be having an idea. The journals now, single reviewers, two reviewers, three reviewers, like that. Three reviewers papers are more standard, like IEEE. Two reviewers and single reviewers. So initially, instead of foregoing your confidence only to single reviewer journals, thoroughly discuss with various researchers working in the area of work and always speak about limitations of the tools. And please do remember, your dedication, commitment, perseverance are very important for the execution of the work. Aim for high quality PhD. Do not aim for exclusively PhD. And PhD 10 సార్లు చేయం, ఒకేసారి చేస్తాం. ఆ ఒకేసారి చేసినప్పుడు మంచి పిహెచ్డి, హై క్వాలిటీ పిహెచ్డి చేయండి. పెళ్ళి ఒకేసారి చేసుకుంటాం, 10 సార్లు చేసుకోం. ఆ మ్యారేజ్ చేసుకున్నప్పుడు అమ్మాయిని చూసాడు, మంచి అమ్మాయిని మనం ఎలా సెలెక్ట్ చేసుకుంటాం, లేదా ఆడపిల్లలు మంచి అబ్బాయిని ఎలా సెలెక్ట్ చేసుకుంటారో అట్లాగే పిహెచ్డి చేసేటప్పుడు ఒకేసారి చేస్తాం. ఒక మంచి వర్క్ చేస్తే దానివల్ల మీ లైఫ్లో అట్మోస్ట్ సాటిస్ఫాక్షన్ వస్తుంది. అండ్ ప్లీజ్ రిమెంబర్ ఇంట్రడక్షన్, literature survey, 3 contributory chapters with 3 publications, and conclusions result the thesis. That is, your first chapter must be introduction. Second chapter maybe don't say literature survey, say image processing algorithms or pattern recognition algorithms, or we should give a different name for that. And 3 contributory chapters with 3 different publications, and then finally conclusions. It results the thesis, and avoid the plagiarism. Do not copy from any works. You try to write your own algorithm by yourself. You try to write the program by yourself. Avoid the plagiarism. Try to solve the industry-oriented problem. As I was telling you, now the entire education dynamics has changed. The education dynamics now, instead of going for a academic research, now people are more interested for industry-oriented research. And submit the research project proposals to various funding agencies like Department of Science and Technology, UGC, AICTE, etc. Develop your own laboratory for research activity. Enjoy your work while doing your PhD. నాకెందుకురా బాబు ఈ పిహెచ్డి నేను చేయలేకపోతున్నాను అనుకుంటూ మీ అంతటా మీరు బాధపడిపోకుండా ఉండి మీరు హై క్వాలిటీ రీసెర్చ్ని మనం ప్రొడ్యూస్ చేయాలా అని చెప్పి మీ వర్క్ని మీరు ఎంజాయ్ చేస్తున్నప్పుడు you never feel the stress of the work. So enjoy your research while doing your PhD. Your analytical skills will improve, your logical skills will improve. Before working for PhD, my thoughts to solve my own family problems are different. After working for my PhD, and the thoughts which I have to solve my own family problems are different. So your analytical skills will improve, your logical skills will improve, your presentation skills will improve, your communication skills will improve. You can analyze within a new perspective the given academic problem, and your innovative approach to solve the research problem, exposure to the international academic society, and your patience, soft thinking, soft way of attending the problem, all are the positive outcomes by your quality research. So I would like to emphasize, when you produce a quality research, your analytical skills will improve, your logical skills will improve, your presentation skills will improve, your communication skills will improve, analysis of an academic problem, innovative approach to solve the research problem, exposure to the international academic society, patience, soft thinking, soft way of working will definitely the best outcomes by your quality research. And this is a sponsored research where you want to submit a project proposal for the funding agency or for an industry. They give the funds and presentation of the proposal, effective utilization of the funds, submission of the outcome. This is considered as a sponsored research. Now people mostly are interested in a sponsored research than the academic research. And industry-oriented research, here also you try to interact with the industry personnel. You try to identify the research problem in a particular industry and submission of the proposal for the sanction of the funds, interacting with the experts from higher learning institutions, and effective utilization of the outcome. This is considered as industry-oriented research. And when you want to publish the research papers, you should select the good journal, a reputed journal, and then manuscript preparation, submission, review, manuscript revision, editorial decision, copyright form, proofreading, and publication. Finally, publish the paper. These are the various stages in the publishing. And here I would like to emphasize 2 parameters, very important, very, very important. One is a publication index, impact factor. Impact factor gives the information about the quality of the journal. What is the quality of the journal is given by the impact factor. What are the author's performance? Yes, Dr. Srinivas Kumar has published so and so paper. And what is the quality of the research of Srinivas Kumar is given by is H index, I-10 index, and number of citations. So, publication index gives the information about the journal. Others indices give the information about the what you call it, the others index gives the information about the researcher or the person who has worked in that particular area and the research problem to get a better outcome. So a publication index and author index both are very, very important, right? So I would like to define what is the impact factor. For example, a particular journal, you take pattern recognition journal, which has got an impact factor of 3 in 2015. Then its papers published in 2013 and 14. That is, in 2015, the impact factor is 3. See the number of citations, average number of citations of each paper published in 2013, of each paper published in 2014, average them. Then that gives the impact factor in the year 2015. I'm repeating again. Suppose let us say in 2013 there are 5 journal papers are there. First paper number of citations you know. Second paper also paper you know the number of citations. Like that you see how many journal papers have come. Each paper how many citations you have got. Average that. Then in 2014 also you have got a publications and average that. Average of each of the all the research papers, number of citations you see, and that is the impact factor in the year 2015. So you try to find a journal having a good impact factor, but please do remember there is an unethical practice that is going on. Impact factor is given by some people, that is not unauthorized group of people, should not be accepted. Only impact factor given by Thomson Reuters is to be considered in calculating the impact factor of a journal. So in 2013, list out the papers. In 2014, list out the papers. And 2013, even each paper, how many citations have come in 2013 as well as 14. In 2014, how many research papers have come, and each paper, how many citations are there, and take the average of all these citations, then it gives the impact factor in the year 2015. So this impact factor is very important. So a authorized group of people like Thomson Reuters is to be considered to see the impact factor, and for such kind of journals only you have to send your research paper. I think it is very clear. The impact factor is nothing but the average of the number of citations of each of the papers published in the previous 2 years given in this particular year. That is considered as impact factor. Then that is impact factor is a journal specific, right? H index. And H index is a very, very important, let us say, Dr. Srinivas Kumar. In the case of Dr. Srinivas Kumar, let us say I have got 9 papers are there. And all these 9 papers, based on the number of citations, you put them in the descending order. That is my, one of my research paper has got 50 citations. So I kept that in the top. And another paper has got a 34 citations. So the next one. Like that, arrange the research papers in descending order, 50 based on the citations, and 50, 34, 24, 18, 15, 8, 9, 6, 2. Then you calculate min of I comma f of I, that is you will get 1 comma 50, minimum 1, 2 comma 34, minimum 2, 3 comma 24, minimum 3, 4 comma 18, minimum 4, 5 comma 15, minimum 5, 6 comma 8, minimum 6, 7 comma 9, minimum is 7, 8 comma 6, minimum is 6, 9 comma 2, minimum is 2. Like that you find minimum of I comma f of I. Among this you try to find maximum. Among this the maximum is 7. So the H index is considered for that particular author is 7. That means what? H index is a number of research papers having at least 7 citations. At least 7 citations in our research papers. In E 50, 34, 24, 18, 4, 5, 6, 7. So my value of H index is 7. That is the way you have to calculate the H index is author specific. Suppose there is another author whose H index is 10 and another author H index is 15. Let us Srinivas Kumar H index is nearly 24. Means Srinivas Kumar is a better researcher because my H index is much higher on 24. So H index is a very important parameter to know the quality of the researcher. Very important. There is another parameter that is called the I-10. Let us say I have got it 25 papers. And out of these 25 papers, only 6 papers are having more than 10 citations. The rest of them are not having that many citations. So, because I have got 6 papers, which has got more than 10 citations, so my I-10 index is 6. I would like to repeat again. Let us say I have got 20 papers, out of which only 6 papers are having citation index greater than 10, then my I-10 index is 6. That way, it is simple and straightforward to calculate. And suppose if I consider the previous case, what is the I-10 index? 50, 34, 24, 18, 15. So the I-10 index for this particular person is 5 because more than number of citations 10 is only 5 papers are there. So for this particular person I can say the I-10 index is 5 citations. Citation, I think I told you already how many people have cited your work is given by the number of citations. So I will give you 5 minutes time. Please relax. I will again join at 5 to 5. At 5 to 5, I will again start my presentation. I stopped at 72nd slide. I will again start working. Another 50 slides are there. I will be presenting them. 73rd slide onwards, I will be discussing. Please relax for 5 minutes. I will be joining at 5 to 5. At 5 to 5, I will join. When I was working actively, I concentrated mostly in the research publications because at that time we are not aware about the patents. But please do remember that the new culture and the dynamics, not new culture, it has come for the last 10 years more. And you please think about the patents. And patents, the intellectual property rights is having several means which you have to consider. One is patents is an intellectual property right. Copyright is also intellectual property right. And let us say industrial design rights is also one intellectual property right. Plant varieties is also intellectual property right. Trademarks is also intellectual property right. Geographical indicators is also intellectual property right. As I was telling you, Graham Bell, not Graham Bell, I think Edison has unmasked with 1,000, more than 1,000 patents. Earlier, people used to think, but when we were working, we have concentrated mostly on the publications and we don't have the patents. But my colleagues in the mechanical engineering department and some of them in the electrical engineering department, they have got more patents. And I sincerely advise you, please do concentrate not only in publications. I don't say you don't publish the research papers, ananu. Kani, please consider not only publishing the research papers, you think about the intellectual property rights like patents, copyright, industrial design rights, plant varieties, trademarks, geographical indicators. More details is not the time to discuss, but these are considered as intellectual property rights and you can go through the internet services and see the details about each of them. And approaching an attorney, manuscript preparation and submission, review, manuscript revision, revision. And there are different stages: patent application, patent publishing, and then commercialization of the patents. There are different means. Unless the patent justifying submit my work for the patent is not acceptable. Unless you finalize, you cannot say that the patent is obtained. So I would like to inform you that another important aspect, that is a plagiarism. And this is a very important, because once when you try to submit your thesis, the thesis is subjected to the Turnitin software. And the Turnitin software will give the information. What is the content that you have copied from the different books or different websites or from different sources? What is the content you have copied, where you have copied, what is the percentage of the information that you have copied? All that information you can get it through plagiarism check. Plagiarism is unethical, and there are clearly the rules and regulations are there. If your thesis is having a copy from different sources, that is what is called as a plagiarism, then you are prone, you must be punished. And my good friend Dr. Uday Bhaskar, suppose if he delivers a lecture, he gives you the information about what is the punishment which you will have if you do the plagiarism, because I'm not interested to go beyond that. But plagiarism is unethical, copying is unethical and incorrect, and it is to be considered as punishable, and you will be punished. And
Jawaharlal
Nehru Technological University, Kakinada, we are making use of a Turnitin software. There are different means. Viper is there, Turnitin is there, Urkund is there. Urkund is another software where plagiarism will be checked. But the standard so far which we consider is a Turnitin software, and the Turnitin software will be helpful to us to know what is the copied content from different sources and what is the percentage of the copy content. And the University Grants Commission has given clearly the instruction, not more than 5% or not more than 10%, is to be considered, and the rest, if you have more plagiarism, then you will be punished. So please do remember, Turnitin software is the one which is being used. Your PhD thesis which you submit should have less than 10% content which is copied from the other sources. If you copy more than that, your thesis, not only thesis will be rejected, there is every chance for cancellation of your PhD registration also. The plagiarism must be very considered very important. Here I would like to tell you one important caution, very important caution. And some of my students, not my students, when I was there as a director R&D, some of the research scholars, not my direct students, they have, నా దగ్గరికి రావడానికి కొంచెం వాళ్ళకి భయం వేసి వాళ్ళ పిహెచ్డి థీసిస్ని తీసుకుని వెళ్ళి వాళ్ళు some other institutionsలో they try to do the plagiarism check. When they are doing that plagiarism check, their thesis has been entered into the database. So whether they got less than 10% or more than 10% is different. But whatever the thesis which has been checked in some other institution where the Turnitin software is there, that particular thesis which they have checked has been entered into the database. Then they have come to me stating, sir, I have checked this particular thesis and we got less than 10%, so I am submitting my PhD thesis. Then I got it checked at my Turnitin software, which is available in our university. Then it has given 100% plagiarism. The reason is it has checked the thesis which they have submitted to me has been checked by itself, which was checked elsewhere. And then the thesis has been checked with itself, so thereby it has got 100% plagiarism. So I sincerely advise you, please take this word as a very important caution. And whenever you check anywhere else, there is one option. The option is when you are checking that particular thesis or that particular thesis should not be allowed to enter into the database. If it is entered into the database, whatever the thesis which you are getting it checked, then the thesis, your own thesis will be checked, your own thesis will be plagiarism checked with itself, then 100% plagiarism will come. So the only solution for this is you must be very cautious. And the caution is that particular thesis should not be checked with itself. So preferably do not get it checked elsewhere. You get it checked only in Jawaharlal Nehru Technological University, Kakinada, with the help of the Director R&D. Otherwise, you take that particular software, get it checked elsewhere, but see that that particular thesis is not entered into the database. If it is entered into the database, the option is given already there in the software, then the thesis will be checked with itself and you will get 100% plagiarism. So you must be very careful when you are doing the plagiarism check. Please do not copy. Try to work by yourself. Try to write the thesis with your own language, and that is very important. And how to write the research paper, how to write your thesis. When you are writing the introduction, you should write the introduction only in the present tense or present perfect. When you are writing the literature survey, that literature survey must be written only in the past tense. When you are writing the conclusion, that conclusion part must be written only in the present tense or present perfect. And see that when you are writing the future directions, then that future directions can be written in the future tense. So introduction must be in the present tense or present perfect, and literature survey must be in the past, and the conclusion must be in the present tense or present perfect, or future directions must be in the future tense. I request you either attend the classes or do your personal works. It is not good to have a crosstalk. As such, that is the reason I never allowed this kind of online lectures when I was there as a director R&D. The university is giving the freedom to deliver the lectures or to listen to the lectures through online instead of allowing you to come to the university for 1 month. That is what you are making use of unnecessarily for other directions. You are doing crosstalk, and whatever the contribution which you are making which you are doing, you are not making use of it perfectly. Whether you leave the class, no problem. We are not the losers. Well, some of the important points to be remembered while writing the thesis: whenever you write the etc., and that etc must be preceded by a comma, etc should be followed by a dot and comma, or if it is the ending of the sentence, then comma etc dot, that's all, and the next comma will not be there. Similarly, when I write a namely, comma, vaz dot comma, whenever I write that is, comma, I dot e dot comma. Whenever I write but, immediately it should be followed by comma. So, however, you should write followed by a comma. Whenever, comma. And wherever, you should write followed by a comma. So, whenever you write that kind of words, it should be followed by a comma. Etc. Comma, etc. Dot comma. Namely, vaz. Namely, vaz means namely, comma, vaz dot comma, and that is comma, I dot, E dot, dot, comma, but, comma. Similarly, however, whenever, wherever, all those words should be followed by a comma. So these are some of the important points to be remembered while writing the thesis. All mathematical equations must be in italic. All mathematical equations must be in italic. And while you are writing the thesis, you write the thesis in the doc format. That doc format generally you convert in the PDF. Earlier, I used to write earlier by using a text or latex. But mostly the people write the thesis in the doc format and get it converted into PDF format. But when you are trying to convert a doc format into PDF format, all symbols like eta, it may not get converted like eta in the PDF format. Suppose when you write sigma in the doc format, that sigma may not get converted properly in the PDF format as sigma. So you must be very cautious when you are converting a doc format into PDF format, whether all symbols are getting converted properly or not, you should check. Similarly, when you write any mathematical equations which are in the italic form, as I was telling you in the previous slide, it should be followed by 3 dots, dot, dot, dot. And please, just few minutes back I mentioned, however, it should be followed by a comma. Thereafter, it should be followed by a comma. Thereby, it should be followed by a comma. Wherein, it should be followed by a comma. Like that, you must be very cautious when you are writing these full stops or the commas. All table captions are to be placed on the top of the table. All figure captions are to be placed at the bottom of the figures. I am repeating again. All table captions are to be placed at the top of the table. And all figure captions are to be placed at the bottom of the figures. All references are to be mentioned in alphabetic order. Typical, whether one is, suppose if I follow the IEEE journals procedure, all references must be mentioned in alphabetic order. Suppose, let us say B.N. Chatterjee. B.N. Chatterjee. Then you should not consider B and N, but you should consider Chatterjee, first letter C. Accordingly, you should put them in the alphabetic order. And the initials are not considered when you write the references. Only the name is considered according to the alphabetic order is to be considered as per the IEEE transactions. So it all depends upon the guide and the discipline and the journal papers which you have. Where you have to consider the alphabetic order or in some other form, then only you have to write your references as a bibliography. And if two others are there, let us say S. Srinivas Kumar and B.N. Chatterjee. Let us say there are two others, S. Srinivas Kumar and B.N. Chatterjee. And when there are two names are there, and those two others names must be mentioned in the references. But when you mention in the thesis, when you write in the thesis, you should say Kumar and Chatterjee. You should not write S. Srinivas Kumar and B.N. Chatterjee. You should not write when you write in the thesis. You can write it in the reference, but when you write in the thesis, you should mention it like a Kumar and Chatterjee. You should not write anything else. You should not write S. Srinivas Kumar or Professor Srinivas Kumar. Like that, you should not write when you write in the thesis. And you should, when you write the thesis, it should be mentioned only Kumar and Chatterjee. But when you are writing the same names in the references, you can mention S. Srinivas Kumar and B.N. Chatterjee. That care must be taken. Suppose when there are more than two others, when there are more than two others, let us say S. Srinivas Kumar, B.N. Chatterjee, and let us say another gentleman is there, some B. Chandramohan. Then how do you write the thesis? S. Srinivas Kumar, B.N. Chatterjee, and B. Chandramohan. Like you should, when you write this in the thesis, Kumar, E.T.A.L. dot. That's all. You should not write all three names. When there are two names, you can write them in the thesis. But when there are more than two others, you should write as Kumar, E.T.A.L. dot, comma. That is called et al. That is clearly mentioned. We can see when references are in the text, you should write if there are more than two others, then the last name of the first author, that is Kumar, and then followed by ETAL dot should be mentioned. And reference number is to be mentioned if it is within the sentence. And Times New Roman for text, 12 font is to be used. Side headings must be 14 font. Main headings must be 16 font, bold. Like this, you must be very, very careful when you are writing the thesis. It should be 1.5 spacing, Times New Roman 12 font for the text. Side headings 14 font, Times New Roman. Main heading 16 font, Times New Roman, bold. Like that only we have to write. Header is to be included for every page. Chapter 6, name of the chapter. That is, header means on the top of the page, header will be there. On the bottom of the page, footer will be there. And the footer, you write the page number. Header, you write the chapter name. And the header, you can write chapter 4 and the name of the chapter you have to write. And page number is to be given at the right top or bottom left. Right? And bottom right. Page number is to be excluded in the page where chapter begins. Very important. Page number is to be excluded in the page where chapter begins. Citation of any work referred is to be included. Very, very important. Whenever you write anything, please do remember, suppose if you have done some work is done by some XYZ, and you want to repeat, when you want to mention that particular work, so and so gentleman has worked like this, you should mention that particular name of the person, and also you give the reference number and you mention that paper in the references. Citation of any work referred is to be included. Very, very important. Without giving the acknowledging that particular person's work, if you write the thesis, it's not correct. Annexures must be given only at the end of the thesis. Annexures must be given only at the end of the thesis. Line spacing, I prefer 1.5 spacing, but some supervisors accept it, or they ask you to write the thesis in the double space. And printing of the thesis is only one side of the page. And some people say both sides if the thesis is a very large volume, but I say only one side of the pages printing may be accepted. Right? And the thesis must be content space. Rather, I will give the next how to write, how to arrange the papers, list of symbols, list of abbreviations, list of figures, list of tables are to be given the Roman numbers like 1, 2, 3, and that is the Roman numbers like 1, 2, 3, and subsequently the numbers may be given for the chapters. When you write, the page numbers must be given as 1, 2, 3, etc. That is list of symbols, list of abbreviations, list of figures, list of tables. They should not be given. They should not be given the numbers like 1, 2, 3. They should be given Roman numbers 1, 2, 3, and subsequently the numbering may be given as 1, 2, 3. Right? That is English. And abstract is to be preceded by a contents. I'll tell you how the thesis is to be arranged. The arrangement of the thesis is like this: title cover, certificate, acknowledgements, abstract, contents, list of abbreviations, list of figures, list of symbols, list of tables, and then followed by chapter 1, chapter 2, chapter 3, chapter 4, chapter 5, chapter 6, references, annexures, list of authors published, referred in thesis, publications, and brief biodata of 1 page with address, mobile number, and email address. This is the content of the thesis. I'm repeating again. First one is a title cover. The second one is a certificate, acknowledgements, abstract, contents, list of abbreviations, list of figures, list of symbols, list of tables, chapter 1, chapter 2, chapter 3, 4, 5 are the contributory chapters, chapter 6, references, annexures, list of others publications referred in the thesis, publications, main publications can be included, and brief biodata of 1 page with address, mobile number, and email. This completes the thesis. Then you can submit. Please do remember all the 3 chapters, contributory chapters, chapter 3, chapter 4, chapter 5 must be 3 published papers, or they should be related to the patents. and unless the patents are obtained, you cannot accept them as a contributory chapters. So you must see either published, or you can say that they are got a patents, either of them. And please remember, whenever you write the thesis, you should not write the thesis in active voice. You should write the thesis only in the passive voice. That means I, we, me, us. This kind of words or active voice should not be used. And please remember, chapter 6, and very, very important is you should not use one sentence is active voice when you write the thesis. It is not acceptable. Only it should be written only in the passive voice. Then another important thing is when you are writing the organization of the thesis, very, very important. If the most of the textbooks are also they are doing the same mistakes, it should not be done like that. I'm repeating again, this should not be done like that. But unfortunately, the authors of the textbooks are also committing the same mistake. Chapter 6 presents the conclusions in the future direction. This is not correct. Chapter 6 never presents. Concluding remarks in the future directions are given in chapter 6 is correct. I'm repeating again. Chapter 6 presents the conclusions in the future directions. This sentence is not correct. Concluding remarks and future directions are given in chapter 6 is correct. So you try to see that when you are writing the organization of the thesis in the first chapter, then you should be very cautious that the chapter 6 presents the conclusions in the future directions. It's not acceptable. You should write that concluding remarks and the future directions are given in chapter 6. That is correct. You must be very, very cautious when you write the thesis. And when you write the thesis, 1.5 left margin, 1 inch right, 1 inch top, 1 inch bottom margins are to be considered. Why I am considering left margin to be more, 1.5 inches? Because 0.5 inches of the left margin will go into the binding. So all four sides will be equal. So 1 inch margin will be there. So you must be very cautious when you write the thesis. 1.5 left margin, 1 inch right top and bottom margins are to be considered when you write the thesis. Then printout may be taken. And I sincerely advise you, the thesis is the one which will be with you and with your children, with your grandchildren. And say that I did my PhD from IIT Kharagpur, I did my PhD from so-and-so, and from Jawaharlal Nehru Technological University. I have got so-and-so publications. It's a privilege to you. I told you at the beginning itself. You will do PhD only once in your lifetime. You will marry only once in your lifetime. With the way you try to select your wife or a husband, you must be equally good in doing the quality work. So when you are writing your PhD thesis and taking the printout, you take the printout in 100 GSM paper. You know, the reason is when you take the printout in 100 GSM paper, that will be long lasting. Suppose if you take 60 GSM or 70 GSM or 80 GSM, the paper will be thin and it is prone to forgo its ambience, it may get torn. So I sincerely advise you to take the print only 100 GSM paper. And do not write any sentence with the two. To do this, to solve this problem, do not write like that. You should write the thesis only in order to solve this problem. Right? That caution must be taken. And latest references must be given and details are presented in the text also. When you are, well, let us say, working in the year 2025, let us say you are submitting your PhD thesis in the year 2028, though you start your work in the year 2013 base paper, but you should mention the latest references of 2027, 2028 papers also must be given in the latest references and what they have done and how your work is superior to their work. You should mention that is latest references are to be given and the details are to be presented in the text also. And when you are writing the thesis, you must take another important caution. The steps of the algorithms are as follows. You let us say you have developed one algorithm, and I am giving one example. That is step 1, step 2, step 3. Then you write the steps. That is not correct. That is not correct. It should be written as the steps of the algorithm are as follows: 1, 2, 3. That is, you should avoid the redundancy when you are writing the thesis. I am repeating the word I'll give an example also here. Step 1, step 2, step 3. If you write it is not correct, it should be written like 1, 2, 3. Like the steps of the algorithm are as follows: 1, 2, 3. That is, when you are writing the thesis, redundancy is to be avoided. That is important caution that you should take when you are writing the thesis. And when you are writing any abbreviations, like let us say support vector machine. So when you write support vector machine, you can write SVM subsequently. But when you write for the first time in the thesis support vector machine in brackets SVM, but subsequently you can mention SVM. You need not repeat support vector machine repeatedly in the thesis. Thereby, you can avoid the redundancy and you can write SVM in future. But when you write for the first time the support vector machine bracket low SVM, that must be taken care of. And when you are writing the thesis, you may have utmost respect towards your teacher or to your madam. You don't write Doctor, MS, Miss or Professor. Don't write. So B.N. Chatterjee. B.N. Chatterjee is my supervisor. So that name is I'm giving you more repeatedly. You should not write because I have got utmost respect on Dr. B.N. Chatterjee, Professor B.N. Chatterjee, Sri B.N. Chatterjee. You should not write. Only B.N. Chatterjee. Right? Even when you are writing a research paper, you should say only B.N. Chatterjee. So suppose you have got utmost respect in your teacher, let us say Professor Krishna Prasad. You should not write Professor Krishna Prasad. You should write, say M.H.M. That's all. But you should not write Professor, Doctor, and Miss. This kind of words you should not write when you are writing the thesis. And research paper should be authored only by the research scholar, supervisor, and co-supervisor. Because if you have utmost affection towards your friend, you give him a very good gift, but don't include his name in your research paper. So research paper should be authored only by the research scholar, supervisor, and co-supervisor. And if you write more names, it's not correct, right? So try to include only supervisor, co-supervisor, and research scholar. There are some supervisors, unnecessarily they include the names of 10 people, 20 people, 5 people, 6 people, and unnecessarily they include the names. Thereby, that is not correct procedure, right? So research paper should be authored by research scholar, supervisor, and co-supervisor only. Right? See, this slide is very, very important, which should be an eye-opener for you when you start the work. Sometimes you need to look at the life from a different perspective. And when, see, all the birds are looking at one direction, but one bird is looking at the other direction. And the reason for making, the way that particular bird is looking at the other direction may give a beautiful outcome, excellent outcome. So you should not beat the beaten path. I'm repeating the same word. Do not beat the beaten path. Try to find the innovative path for the solving the problem. So you should look at the different direction to get a different perspective. The slide is most important and it should be eye opener to all the scholars. This is about the research methodology. And as for the industry 4.0 technologies, another 37 slides are there. And that particular part I'm not discussing. The reason is already 2.5 hours discussed. And this part I'm leaving it. You can go through the slides. And industry 4.0 technologies is having a first revolution, wherein it is a mechanization. Second revolution is electrification. Third revolution is automation. And the fourth revolution, and it is a cyber physical system, real objects in the virtual process are linked. So first revolution is mechanization, second revolution is electrification, third revolution is automation, and fourth revolution is cyber physical systems. That is the real world objects in the virtual process are linked. And there are some technologies. One is the big data analytics, wherein 4 V's are very important: volume, velocity, veracity, and variety. Veracity means certainty of the data. Variety means diversity of data, different data, veracity, certainty of the data. The data is correct or not, veracity, variety of data, voluminous data, velocity of the data. All these four V's are considered when you try to analyze the data. Volume, velocity, veracity, and variety. These are considered four V's of big data. And please do remember, you are given abundant data. And from the data, you have to get that information. From that information, you have to get the knowledge. From the knowledge, you have to get the wisdom. That is data, information, knowledge, and finally the wisdom. And finally, the outcome which you should get is the wisdom to your big data analytics. Data, information, knowledge, and then the wisdom. It is the prism that is to be considered and which is very important when you are working on the big data analytics. It is one of the important industry 4.0 technologies that is called big data analytics using artificial intelligence and machine learning. And there are four types of data analytics. One is a prescriptive, predictive, diagnostic, and descriptive. The slides will be given to you. You can go through them in detail. These are four types of data analytics: prescriptive, predictive, diagnostic, and descriptive. The details are also given the right side of the diagram. You can go through them. And we are speaking about the artificial intelligence. Artificial intelligence, as I was telling you, it is not one subject. Artificial intelligence means it may be a machine learning, or it may be a natural language processing, or it may be a speech, or it may be expert systems, it may be planning, scheduling, and optimization, it may be robotics, it may be vision. Artificial intelligence means it is a combination of many subjects: machine learning, natural language processing, speech, expert systems, planning and scheduling, robotics, and vision. That is a one subject which is ruling the future of our engineering. It penetrates into every area, every topic, and unless and until you are changing your mindset to the education dynamics, which I have repeatedly mentioning even in earlier also, you have to master the artificial intelligence and apply that for your own work. Then only your work will be wise to get published. So please master the artificial intelligence and make use of it as a tool in your area. That is very important. And there's a third one is so far what I discussed about the data analytics using artificial intelligence and machine learning. And another one is a system integration. And you see the system integration is the one where you have to consider horizontal integration and as well as the vertical integration. And you are having a different levels to take an appropriate decision in the top. Let us say I'm giving a very crude example. Here in a university system, you can consider the faculty, all faculty members are at the lower level. Then next level is heads of the departments. Next level is the principals. Next higher level is the registrar. And next higher level is the vice chancellor. And next higher level is the principal secretary. Next higher level is the education minister. So you can see that all lower levels, the faculty level is, if you try to integrate, then it is nothing but a horizontal integration. Or similarly, if you integrate all the teachers, all the heads of the departments, let us say there is a second level integration. And if I consider all principals, and let us say there is another level of integration to take a decision making. And suppose if I consider the next level registrar, and the next level is the vice chancellors, next level is the principal secretary, next level is the education minister. That is, at each level the decision making is to be taken, and all levels are to be integrated to take the final decision. So each level is a horizontal integration, and level to level is nothing but the vertical integration. I have given a very crude example. Similarly, you can see in any industry, from the floor level to the top management, at each level you have to integrate, and finally decision is to be taken at the highest level, maybe at the CEO level. Then it is horizontal to vertical integration, and that is what is required for an appropriate decision making. So system integration is one industry 4.0 technologies. And the third technology is the cloud services. And I would like to say infrastructure as a service. Suppose if I want to purchase a computer with a very, very high-end computing system, then or if I want to have a very good high quality and high speed memory with high storage capacity, then naturally it is a cost is a very important point to be considered. So Microsoft Azure and various cloud services are there, and you can hide those cloud services and say infrastructure as a service. Similarly, platform as a service, or similarly the software as a service. So the cloud services may be considered as infrastructure as a service, platform as a service, and then the software as a service. One of the important work that can be carried out is security. Very, very important point to be considered is the security aspect to be considered when you're working in the cloud computing. You can as well work in the cloud computing. And that is what I mentioned: software as a service, platform as a service, infrastructure as a service. And there are two types of clouds: public cloud, another one is a private cloud. And private cloud means, let us say, there is one cloud that is used only within your organization. The Microsoft employees can make use of that particular cloud. Others cannot cannot use that cloud. Then it is considered as a private cloud. Similarly, the public cloud is the one where people from Microsoft, Azure, or any other people can make use of the same cloud, or the public can use the same cloud. Then the public cloud is there, private cloud is there, and the third one is a hybrid cloud, where both public and private clouds may be there. And another important Industry 4.0 technology is augmented reality and virtual reality, which is mostly being used by the entertainment purpose, and it is being used by the tourism purposes, and where augmented reality and virtual reality is the one which is another Industry 4.0 technologies. I'm going a little bit fast because time is already 2 hours 40 minutes. And IoT, Internet of Things. And the people say Internet of Things is something new, but I say it is not something new. It is a convergence of many subjects: computer networks, big data analytics, intelligent sensors, intelligent controllers, security, database management, embedded systems, communication. So many subjects, when they converge, it results in one new subject that is called as a Internet of Things. Even when I was there as a Vice Chancellor at Jawaharlal Nehru Technological University, Anantapur, we started MTech Internet of Things. It is the Industry 4.0 technologies in collaboration with electronics company. Today, most of the railway systems are working on the area of Internet of Things. And another one is the autonomous robots. As I was telling you, robots is the one area where active working is carried out, and it is a multidisciplinary. It is an interdisciplinary area, and robots is one area where active work can be carried out. Advanced manufacturing or additive manufacturing or 3D printing. Then when you make use of in the manufacturing process, the areas like artificial intelligence, machine learning, or Internet of Things, or cloud computing, or data analytics, then the manufacturing process may differ, and it may give a qualitatively and quantitatively also the outcome may be higher than the earlier. So advanced manufacturing systems is one area where it can be considered as a Industry 4.0 technologies. And I consider the digital twins is another area where active work can be carried out. I've got a beautiful book, excellent book. And that book, if your expert, if the gentleman, the director accepts, then I don't mind to give it to him so that he can send that book also, Digital Twins. And this is the one where physical process is simulated. And you can understand the physical process through simulated process. Mostly it is being used in the automobile system. And the automobile system, let us say if we consider, it depends upon the brake, it depends upon the air conditioning system, it depends upon the engine, it depends upon the clutches, and it depends upon many other parameters, and depends on the performance of many other parameters. But if you try to simulate that, when the physical system and simulated system, both when we observe, when the physical system is likely to fail, you try to understand and get the information through simulated process. And this area is called as a digital twins, where it is having a number of applications. One example I quoted in the automobile industry, where every physical process can be simulated. That is what is called the digital twin and system simulation. Right? I'm skipping some of the slides. Cyber security is one area where active work can be carried out. And today, whatever the UPI, the transfer of money from one account to another account is going on, that must be with secured architecture. So the cyber security or the blockchain technologies is another important area where you can contribute good work. And benefits of the industry 4.0 technologies, you can have intelligent products, intelligent factories, and please do remember, whatever the work which you contribute, they may be please linked with industry 4.0 technologies, then you will have a good outcome. Please do remember, earlier also image segmentation is there, image compression is there, image mosaic is there, and many other topics are there. But all those topic algorithms, now they can be linked with industry 4.0 technologies, you can get a better outcome. And the difference between the digital twins and cyber physical system, Internet of Things and cyber physical system, research perspective. And I would like to give a last slides, that is the importance to the research in the national education policy 2020. You can see 0.69% of the GDP, gross domestic product, is used in India for the research purpose, while in the US it is 2.8%, 4.3% in Israel, and 4.2% in South Korea. So in the national education policy, they have given a recommendation that the percentage of the GDP for research purpose, it must be increased to see that it becomes a Vikasit Bharat, developed nation. It can become by 2047. Only if the research outcome is improved. 3 or 4 years time to produce nation, and there are many funding in quality research. And holistic development education. Earlier people you say pharmacist, now you should become a multi-economics, management, engineering, and you should start multiple disciplines. And holistic development with multidisciplinary campuses is one of the important feature of the national education policy. Learner-centric education in lieu of the teacher-centric education. And people used to deliver the lectures and they leave. But now the entire education should be a learner-centric education in lieu of the teacher-centric education. And so the teacher is now more accountable, and you should create the platforms for the learner. It may be a self-learning, it may be a collaborative learning, it may be a flipped learning, or it may be experiential learning, whatever may be the learning process. But the teacher should create the more learning platforms, and the teacher is accountable for the learning aspects of the student. So a learner-centric education in lieu of the teacher-centric education. Multiple exit and multiple entry. The teacher may leave after, the student may leave after second year, but still, though he doesn't complete the rest of the 2 years, but still he should be given a certificate. Suppose if he leaves at the third year of BTech program, he should be given a diploma. If he leaves at the end of the fourth year, then he can be given a 4-year program for BTech. Or if he leaves, if he stays till the fifth year, and if he completes additional subjects, then he can be given a BTech honors or MTech program. So multiple exit and multiple entry means, suppose if he completes after second year and he leaves because of some his personal work, after 4 years or after 5 years, he can come back and join in the third year and complete the third year and final year. So that is the reason it is considered a multiple exit and multiple entry. And regional languages must be increased. Must be emphasized. And not only in English, we should be in a position to teach English, Telugu, Hindi, in any language the student is interested, that regional languages should be emphasized. Gross enrollment ratio is to be increased from 28% to 50% by the year 2045 in higher education. Whereas in primary education, it should be raised to 100%. That is, gross enrollment ratio means the students who are eligible, who are actually studying, right? That the percentage between the actually studying and the students who are eligible must be increased from 28% to 50% by 2035. Equity, quality, accessibility, affordability, and accountability are to be considered. All students are equal to me. The quality of the education, and even if the student is in the remote place, then through our communication system, the student should be in a position to accessible. Affordability, and that is a financial aspect. Accountability, the teacher is accountable. Everyone, every stakeholder is accountable. The equity, quality, accessibility, affordability, and accountability. And another was the knowledge important, skills important, as well as the value system is also important. And National Research Foundation is getting established, through which the research is to be given much emphasis. Autonomous degree awarding institutions and teaching incentives and research institutions like that. The institution must be divided into three categories: teaching intensive or research intensive or autonomous degree awarding institution. Like three categories, the institutions will be classified. And then international higher education is emphasized, teacher education is to be emphasized, emphasize vocational education as a part of the higher education, technology enabled education, and the four pillars the Higher Education Commission is thinking of is the National Higher Education Regulatory Council, National Accreditation Council, Higher Education Grants Council, and General Education Council. National Higher Education Regulatory Council, where the regulation of the institution is given importance. Accreditation, today we are having a NBA, NAC, or NIRF ranking, like the different bodies are there. Now, all should be come under one umbrella that is called as the National Accreditation Council. Higher Education Grants Council funding will be taken care of by the Higher Education Grants Council, and General Education Council, where the curriculum and other aspects are given importance in the General Education Council, like the establishment of Higher Education Commission with four verticals are to be considered. And important feature of the national education policy, as I was telling you, knowledge, skills, and values are to be given emphasis. Equity, quality, affordability, accessibility, and accountability are to be given emphasis. And National Research Foundation, which I discussed, and this is a very important aspect which I would like to present. And I have a great honor to our great industrialist and a philanthropist and a great legendary person, Dr. Ratan Tata. I don't believe in taking right decisions. I take decisions and then make them right. So always believe in your ability and efforts. Never think of others to help you. I'm repeating this word. So always believe in your ability and efforts. And this is very important aspect. And I request you sincerely to work hard, get your PhD. Don't think of others to help you. Thank you. I invite